Greetings, environmentalists, and welcome to our Resource Conservation Recovery Act and Waste Management Lecture 7 for Environmental Science 1301. So let's move forward and talk about our learning objectives today. We're going to describe the historical significance of the Solid Waste Disposal Act of 1965, which set a precedence for rule-making changes in all disciplines of the environment. We're also going to discuss the amendments to the Solid Waste Disposal Act, which was the Resource Conservation and Recovery Act, and its various subtitles that we feel are applicable to our discussions today. We're going to learn how to distinguish the difference between illicit and characteristically hazardous waste. We'll determine how universal waste, municipal solid waste, and medical waste are classified and how they're different from hazardous waste. And we're going to focus on what cradle-to-grave responsibility of the waste generator means and how it applies to the concept of a specific case study. So we're going to start by examining the Solid Waste Disposal Act, and we're going to look at what happened in 1965 and subsequently what led to the passage of RCRA. So let's get started. The Solid Waste Disposal Act was passed in 1965, and initially what happened was U.S. Congress passed this law to protect human health and the environment from potential pollution caused by solid waste being disposed of in our land. Specifically, they wanted to promote natural gas, which is renewable natural gas energy, RNG, recycling at landfills. That had not been a big push, and this law helped promote that. Second of all, they wanted proper disposal of waste to reduce groundwater and land pollution. As people drink the groundwater and people live on the land. And they wanted to encourage waste reduction and waste reuse. So not everything that was being thrown away would have to go to a landfill. U.S. Congress became concerned about the amount of space that remained both in small and large trash dumps, otherwise known as landfills, and that space would not be sufficient or able to sustain the volume of waste being received at these locations. In addition, the health risk of improperly disposed of or managed waste posed an imminent risk for human health and the environment. Something needed to be done to manage this. Well, since those rules were passed in 1965, a different set of rules would be added. A series of amendments were made, and they're known as RCRA, Resource Conservation Recovery Act. I guarantee you need to know that for your test. Essentially, this put a new lens on the face of the Solid Waste Disposal Act by requiring proper management and disposal of hazardous and industrial waste. Up until then, really, it was solid waste in general that needed to be concerned with, and not specific rules for hazardous and industrial waste. So this managed the pollution technologies through specific subtitles for petroleum, storage tanks, landfills, medical waste, and manufacturers. And we're going to look at a handful of that. Before we get started, we need to give a reason for why RCRA even needed to be passed in the first place. And the story's a bit sad, and I want you to put on really careful thinking caps about this one. If you've heard about Canal, I think you're going to get some information today that may surprise you. So let's watch a short video, and we will learn a little bit about it.
In 1892, William T. Love proposed connecting the upper and lower Niagara rivers by digging a 6-mile canal to provide cheap hydroelectric power to the area. This region, located in New York State, became known as Love Canal. However, after only a mile of the trench was dug, the project was abandoned due to a lack of funding. The canal then became a landfill for chemical waste used by Hooker Chemical Corporation, the City of Niagara Falls, and the U.S. Army. Approximately 22,000 tons of at least 200 different chemicals were dumped by Hooker Chemical Company from 1942 to 1953. Then, in 1953, they sealed the landfill with a clay cap to contain the chemical waste and sold the land to the Niagara Falls Board of Education for $1. Despite Hooker's warnings of the potentially toxic nature of the property, the city proceeded to build an elementary school on the newly acquired land. In addition to the elementary school, hundreds of homes were built on the periphery of the former landfill site. This development of the land caused cracks to form in the clay barrier beneath. Soon after, residents began to complain of strange chemical odors, minor explosions, and black sludge seeping into their yards and basements. Children playing outside would return home with minor chemical burns on their feet and legs. These complaints began to surface in the early 1950s, but were not investigated until the late 1970s. Subsequent environmental sampling in basements next to the waste site detected over 200 different compounds. Of those, at least 12 are known to cause cancer. Additionally, high levels of dioxin, a chemical that the New York State Health Commissioner described as the most toxic substance ever synthesized by man, were found in the water. Many of these chemicals eventually migrated to nearby creeks, bioaccumulating in the tissues of plants and animals in the larger Niagara Falls area. Thus, the water contamination had negative repercussions on the entire ecosystem. With test results pouring in regarding the toxicity of the chemicals surrounding them, the residents of Love Canal became increasingly distressed. Lois Gibbs, the mother of a child at the local elementary school, began organizing the community and formed the Love Canal Homeowners Association in 1978 without any prior experience in activism. Her organization faced tremendous difficulty in getting the government to acknowledge that there was a problem, much less respond to it. Eventually, a very limited evacuation ensued, and a cleanup of the canal site began. The government only paid for the evacuation of pregnant women and children under the age of 2. Thousands of outraged residents still remained in danger. Then, in 1979, the EPA announced the result of blood tests that showed chromosome damage in over 30% of the residents of Love Canal, as opposed to only 1% in a typical population. Additionally, many children had birth defects. In 1 year, out of 22 pregnancies, only 4 babies were born normally. For example, one child was born with a cleft palate, deformed ears, impaired learning ability, deafness, and an extra row of teeth. By 1980, the residents had become so desperate that they took 2 federal officials hostage and demanded that the president take action. Amid a media frenzy and an upcoming presidential election, President Carter took note and a federal state of emergency was finally declared. A few months later, Congress authorized funding for the permanent relocation of all Love Canal residents. Finally, after years of collective effort and activism, the Love Canal residents seemed to be saved. Years after the fact, we can now see how the Love Canal disaster led to several positive developments in the United States. To help ensure that nothing like this happens again, many national legislative changes were enacted to help protect people and the environment. Love Canal also led to the creation of Superfund, a governmental program established to help clean up hazardous waste sites and hold companies accountable for their own environmental irresponsibility. More than just structural changes, the Love Canal disaster also significantly shaped how Americans view hazardous waste and environmental protection as a whole. It spawned a grassroots movement that gave Americans a voice on environmental issues and championed the powers of democracy.
Now that you watched the Love Canal video and you have a better sense of what happened, let's dig a little deeper. Hooker Chemical Company purchased the land and used it for about a decade to dump industrial waste and hazardous waste, and then they covered it up with clay in 1953. They sold it to the city for $1, the absolute worst purchase ever made by a municipal entity such as a city. Let that be a lesson learned to you. Don't purchase something that's cheap like that and expect it not to have problems. You get what you buy, right? Or what you paid for. Nevertheless, in the late 1950s, Love's dream community began to get built. And this is the sad part about it. 100 homes or so were built and 1 public school were put on top of the contaminated site. Industrial and chemical waste had been dumped there for a decade by the company. 82 different compounds were detected by EPA after the investigation started. And 11 of those ended up being suspected carcinogens. So what had happened was the waste actually kind of moved upward through the land, up through the clay, and into the soil, and even into the backyards and basements of 100 homes and one public school built on top of the canal. So when we link Love Canal to RCRA, you heard in the video how it actually led to the development of Superfund. Well, it also led to prompting the need, along with a few other case studies, of developing rules and regulations that would prevent the Love Canal catastrophe from happening again, or put measures in place that were enforceable. The Environmental Protection Agency is the entity that oversees RCRA. So they had already passed the Solid Waste Disposal Act in the 60s, and they passed in 1976 RCRA. But it would be in the 80s that they would pass these subtitles that address specific cases about solid waste that was hazardous, industrial, and a couple of other areas. These are not the only subtitles that were passed, but they're some of the majors. Subtitle C dealt with hazardous waste. Subtitle D dealt with municipal solid waste, so things that go into a regular landfill. I dealt with petroleum storage tanks that were leaking, and J dealt with how to dispose and handle medical waste. When we look at Subtitle C was just an enormous change to the rules. It mandates that the hazardous waste generator properly identify, classify, manage, and dispose of hazardous waste within the United States. And it created something known as a manifest. That's what you see in the right here. This is a hazardous waste manifest, or at least the original white page of the manifest. And this is the form in which hazardous waste must be manifest when it's sent for proper disposal. The absolute most important change, and guaranteed test question I might add, that made or occurred in Subtitle C was who was responsible for the waste. Ultimately, it was the waste generator. No longer was it the waste transporter. So the generator actually owned that waste, and they owned it from cradle to grave. So that is a common term. And if you think of cradle, you think of a baby in a cradle, and you think of a grave, someone that's died being buried. The idea is that from the birth of that waste till the time it's properly disposed of, that waste belongs in the responsibility of the person who made it or generated it. They're legally responsible for it, even truly after it's been buried. They never really 100% get off the hook. But at least you know when it's been properly disposed of, you can have a sigh of relief. So that's an important component of Subtitle C. Let's get into waste identification, because that's totally directed at what happened with Subtitle C. It required that all waste generators perform a hazardous waste determination. So basically, that requires a waste generator to properly identify their waste as either hazardous or non-hazardous. It's as simple as that. Is it haz? Is it non-haz? There are 3 criteria used to fulfill these requirements. And the first one is your waste on one of a list? So is it a listed hazardous waste? Number 2, is your waste characteristic? And we'll get to that. So the third one is, do you have enough process knowledge, or what I like to call good old-fashioned common sense and experience with your waste, to know that it is hazardous? So these are the 3 things that people use that are legally accepted ways to prove whether a waste is hazardous or non-hazardous. Some of these indicators over here could help you identify, maybe like if it's toxic, that's a characteristic, if it's corrosive, if it's ignitable, not just flammable. These are things that are used to help us determine if something is hazardous. So the first thing you got to do before you even start this process of determining if something is hazardous or non-hazardous, you have to ask yourself a fundamental question. Is what you have necessary to call a waste, or can it still be reused for its intended purpose? Here's why that's such an important question. I own an environmental consulting company, and one of the things that I will help people with on their hazardous waste determinations is to determine, do they even have a waste to begin with? Do I even have a need to get rid of this? Let me qualify that and say it would be like you looking at your degree plan and saying, all right, here are all the classes I need to graduate, and then you decide to take something outside of that plan, it doesn't even apply to you so to graduate. So that's kind of like what this is. If it's not a waste, RCRA does not apply. It doesn't mean that there's not material rules that would apply for how those materials could be handled at the workplace by OSHA that you learned about in last lecture, or maybe that the materials would be handled on the roadways by the Department of Transportation. But nevertheless, on site where that waste is generated, you have to ask yourself and determine that you have a waste, not a product, before you start applying RCRA rules. So what's the definition of a product? Anything that can still be used for its intended purpose. An example would be scrap metal that can be recycled. So that would not even fall under the definition of a waste. However, a waste, as obvious it may seem, is any item that can no longer be used for its intended purpose. Okay, so let's say it's contaminated sludge or wastewater. Let's say it's that same scrap metal now that's been contaminated with something like hexavalent chromium. So now it needs to be gotten rid of. If it needs to be gotten rid of, it falls into the waste category. To correctly answer if it's a product or a waste question, the waste generator is required by RCRA to conduct an assessment. This is called a hazardous waste determination, known as an HWD. This is an assessment conducted by the generator to determine that simple answer, is it a product or is it a waste I need to get rid of? And they have to do this across the entire site. In other words, they have to look at every kind of thing that they throw away or that they generate that could possibly be a waste. And all they have to do is do it once and have it on file, because what they generate determines if it's hazardous, what they're going to have to pay for, and how they're going to have to dispose of it a little later on. So process knowledge, in simplified terms, is the importance of knowing how a waste was generated in order to handle proper disposal. It asks all these questions over here to the right. If somebody's been working for a company for 30 years, they're probably going to know enough about that chemical or that waste that they've developed over all those years and produced that it probably is in the realm of being hazardous, and maybe an additional investigation or test needs to be run on it to confirm that before you eliminate it as a hazardous waste at your site. One for sure way to have a hazardous waste is to determine that there's a chemical in it that is on the hazardous waste list, and there are over 400 different hazardous waste chemicals. Of course, there's volumes that make something hazardous on each of these lists, and you have to look at them. So there are P, F, K, and U list, and we'll be looking at all of them here shortly. The bottom line is, if it meets one of those listed chemicals, it's hazardous. So how do you know? You have to look at the material safety data sheet and have some information about your product and how subsequently it becomes a waste. So let's look at the first two of the list, and then we'll evaluate the others. The P and U list deal with unused hazardous chemicals, while F and K deal with spent or used chemicals in some kind of manufacturing process. So in other words, P and U never got to be used in the manufacturing process to begin with. So how does this happen? Typically, manufacturer overbuys, or they have a bottle of this stuff that they purchased and it goes out of date, out of spec. So EPA designates the chemicals on these two lists as pure and commercial grade formulations of very specific and certain unused, keyword there, hazardous chemicals requiring disposal. So for a waste to be considered a P listed waste, it must be acutely hazardous. I'll get to what that means shortly. Or U listed, that means non-acutely hazardous. And it must meet the following three criteria. Number one, the waste must contain one of the chemicals listed on either the P or the U list. The chemical in the waste must be unused. The chemical in the waste must be in the form of a commercial chemical product that is 100% pure or the sole ingredient of a chemical formulation. So let's talk about the difference between P and U. A couple of ways I remember this. It's not that it's written in the rules this way. P for potent or poison. It doesn't take much to kill you, okay? That's acutely hazardous. U for ugly, and it still is can kill you, but it takes a lot more of it to do it. So if you got P or U listed waste, P is the stuff you don't want to have on site because it doesn't take much to make something really, really potent. So those should be your trigger buzzwords when you're remembering it. P and U. P for potent or poisonous, U for ugly and unlisted, right? In other words, it's not unlisted, unused, because both of these chemicals have not been used, but they each serve as a reminder that if your chemical's on this list and you've used it or you have it on your possession like it's in your place, it's hazardous. The second two lists are the K and F listed waste. EPA identifies waste generated or spent from common manufacturing and industrial processes as hazardous. These two lists, the K and the F list, mean that they've been used in the production, manufacturing of something. So let's look at K listed waste. These are very kind of weird stuff, really. It refers to hazardous waste generated from a very specific type of industry, such as creosote from a railroad manufacturing company, where the ties that they make for railroad that I showed you in our last lecture, that would be an example of a K listed waste. But an F-listed waste refers to hazardous waste generated from non-specific sources. These could be things such as solvents from a painting operation, and solvents would be one of the most common types of spent hazardous waste that you see out there. So a lot of what businesses may have may be F-listed waste, where they very seldomly have K, P, or U. Another way to identify if a waste is hazardous is if it's characteristically hazardous. What does that mean? Is a hazardous waste characteristic which has a property indicating that the waste poses a sufficient threat to merit regulation as hazardous. So the EPA has established 4 hazardous waste characteristics, and there's a trick to remembering them. The first letter of each of the items or the characteristics. T for toxicity, R for reactivity, I for ignitability, and C for corrosivity. So we're going to look at each of those, and usually when people look at these, they have different images and thought patterns about them. So here's an easy way to remember that. Is there's a trick, TRIC, and the first one, toxicity, deals with any waste that leaches out at a specific level set by the EPA on the D list. D as in Delta. What does that mean? Basically means like lead. If you have lead, the limit for it to be toxic is 5 milligrams per liter. That would be a great bonus question for a test. So if that's the case, then you look at that, all right, so if it's 4.9, it's still pretty ugly, but not ugly enough to merit being listed hazardous. Instead, it would be called an industrial waste. But as soon as it hits that 5.0, it becomes toxic, and EPA recognizes it as toxic. The reactivity is any waste that undergoes a chemical reaction with water or releases certain toxic gases when exposed to acidic or base materials. So that could be something like a peroxide that comes in contact with something and has a reaction and explodes. Ignitability is different from flammability. It already is flammable if it's ignitable, right? This is a waste that has a flash point, meaning if it has a heat source nearby, it will instantaneously combust, and that has to have a flash point of 140 degrees Fahrenheit or less. Guaranteed test question. So when you're looking for solvents, they often can have an ignitable characteristics. You need to try to find ones that have a flash point above 140 degrees Fahrenheit. The C of trick is corrosivity, and that refers to any liquid waste that has a pH of 2.0 or less, so it's very acidic, or on the opposite spectrum, it's very base, and it's going to be greater than 12.5 on the pH scale. So remember, there's a trick to the characteristics TRIC, and each of the beginning letters of the acronym refer to the beginning letters of the word that they represent. So how does a waste qualify as hazardous? Several ways. It's found automatically on the PFK or U list. So that's a check. If it's there, it's automatically hazardous. The waste meets a criteria for either toxicity, Reactivity, ignitability, or corrosivity, check. If it's one of those, it's automatically hazardous. Or the waste is both. It falls in both listed and characteristic. When would this happen? A lot of times solvents are on the F list and they're also ignitable, but you can have multiple times where something's on both, but it only has to be on one. So if your waste falls in either category or both, it's listed and or characteristic, it's automatically hazardous. Only one is required to be met. Understand that, but more than one can apply to the waste for it to be considered hazardous. So let's look at generator status. This is an interesting component of the story of how RCRA works. And basically, hazardous waste generator status is based on how much hazardous waste a facility generates at their site in any given month. The only way to know if a waste is hazardous is to perform that hazardous waste determination. That's why we did that step 1 just a minute ago. These are the written assessments which are required to be kept on site for each individual waste stream. And a waste stream does not necessarily mean like a river. It just refers, waste stream is a common term that translates to meaning anything that's a waste. That can be a solid, a liquid, a semi-solid. There's a whole definition for what a waste is in terms of solid waste. And nevertheless, the waste stream is a specific type of solid, liquid, or gaseous waste. So understand that solid waste does not just refer to brick solid. It also includes liquids and gaseous materials. So when you're doing a generator status, if the waste is proven not to be listed or characteristically hazardous, it is considered non-hazardous, and you do not have to count it every month towards your generator status. That's the bottom line. So doing step 1 right is the only way that you can do step 2 right. Subsequently, do step 3 right. So you have to know what you generate is hazardous. Once you figure out what's hazardous, then the next step where we are now, generator status, takes a hold. Hopefully you have a lot of the non-hazardous stuff because it's a lot cheaper to deal with. So once a generator identifies which specific hazardous waste or waste that they have on site, RCRA recognizes that the facility measure the total weight of hazardous waste they generate each month. And each month is important. So they have to do it by month. In other words, they can't add up their waste by 12 months in a year and divide by 12. It has to be done January for January, February for February, March for March, and so forth, all the way through December and all of December. So it can't be a year cumulative divided by 12. And that'll make more sense in a minute. So generator status for a hazardous waste generator, its status is determined based on the cumulative amount of hazardous waste generated each month at the entire site. So you may have, let's say, 3 or 4 things that are hazardous. You got to count all of those 3 or 4 things every month. You can't just say, oh, one of them was, I had this much of one of them. You have to tell what you had for all of them and then add them together and see what your cumulative weight is for the month. So there are 3 generator statuses, and there is large quantity, small quantity, and then conditionally exempt small quantity generator. So we're going to look at all 3 of these and the stipulations that are required for them because the bigger you are, the more stuff you generate, the more things you have to do. Kind of makes sense, right? So here's what you got to do as a large quantity generator of hazardous waste. The first thing is you must hit the trigger of generating more than 2,200 pounds of hazardous waste per month. What does that look like in terms of volume? Basically, folks, that's more than 5 55-gallon drums in a month. So it didn't put a cap on it, did it? It said they generated over 2,200 pounds. So that means they could generate hundreds of 55-gallon drums. Okay. Now, they can only store that hazardous waste for up to 90 days. We got a clock on this one. And the reason is, let me finish this part and then I'll give you the reason. Before the facility is required to send the waste off for proper disposal. So they got 90 days to get rid of it properly. And the reason they have this clock time put to it is because there's so much of it, there's a higher risk for an imminent threat to human health and the environment should a spill occur. So they're required to register with their state's Department of Environmental Quality and the EPA, and they get a little number, it's almost like a driver's license number, a site ID number for their hazardous waste. Also, they are required to submit an annual waste summary and pay annual waste fees every year based on the cumulative amount of this hazardous waste that they generate. So they have extensive storage requirements, record keeping requirements, and employee training requirements simply because they're large quantity generators. So what does a SQG or a small quantity generator need in order to qualify as SQG? Because you much rather be an SQG than an LQG, a large quantity generator. SQGs generate between 220 pounds to 2,200 pounds per month. So 220 pounds is about half of a 55-gallon drum, up to 5 55-gallon drums in any given month. Now they can store only up to 13,200 pounds of hazardous waste in any given month. So that's about 30 55-gallon drums. And then there starts to be a clock needing to get rid of that stuff for the same reason I listed and said for a large quantity. It becomes a higher environmental risk. So they have 180 days where the LQG only had 90 days, right? And they still have to send it off for proper disposal. Just like the LQG, they had to register and get that site number from their State Department of Environmental Quality and the EPA. Just like an LQG, they have to pay waste fees at the end of the year. So they have to know how much they generated each month, and then they pay an annual, basically, environmental tax, for better lack of words. Because they don't generate as much, they have less requirements for training and record keeping than an LQG. But nevertheless, they still have more than what we would call conditionally exempt small quantity generator. The key two words, conditionally exempt. We call these guys C-squigs, for real. That's what the regulated community calls them, C-squigs. They can generate up to 220 pounds per month of hazardous waste. So less than half of a 55-gallon drum. It's not very much. They can store their waste as long as they want. In other words, there's not a clock. And people are like, well, why is it they should have a clock put on them? Actually, the federal government asked for people in business to help them make these rules, and it would break the bank literally for a really tiny small business who only had just a fraction of an inch of hazardous waste to get rid of every month if we made them have to do it like they do for SQGs and LQGs on a clock. So it may take them 10, 15 years to fill up half a 55-gallon drum. Many C-squids will get rid of their waste regularly because they don't want to be held accountable for it. But understand the law allows them unlimited time to hold on to that waste. They are not required to register with their state's Department of Environmental Quality or the EPA unless they're industrial C-squigs. Different story, not appropriate for this class. It's just, if you run into that situation at a business, give me a call and I'll walk you through it. It is not required as C-squigs to submit an annual waste summary or pay annual waste fees unless they are registered for some reason. So bottom line is they're not required to be registered. So if they do register, they automatically get this little gift in the mail called an annual waste summary, and that's a $50 minimum. Here you go for a piece of paper, submit it back by the deadline or you got penalties. So something to consider when you move to a business and they are registered and they're a C-squig. They must maintain proper hazardous waste shipping and generation records along with MSDS sheets and so forth. So they have some regulations to follow to stay conditionally exempt. So each facility is required to maintain monthly generation records for the total amount of hazardous waste they generate at their site per month. So a facility cannot add waste manifests for the year together from every time they ship to get their total amount and divide by 12 and say, oh, well, I had an average of this in January, an average of this in February, an average of this in March all the way through December. It has to be by month. So they also have to keep these on site in case of an investigation. Well, that brings us to waste accumulation and on-site management. That's the next step. This is step 3. So when the annual waste summary time comes around, it's usually sent out right around December and it's due in January. Isn't that Merry Christmas? You know, Happy News. It's like getting your taxes done. Each registered, and the keyword's registered there, generator stat or hazardous waste generator and facility must report and file a report each year to determine what their appropriate waste fees are. Again, it's like an environmental tax for polluting. The facility is required to disclose the following: two things: the total amount of hazardous waste generated for the calendar year and the total amount of non-recycled industrial class 1 waste. I realize you don't know what class 1 waste is, but you are about to shortly. So if those two things is what the tax is based on, and then they have to pay that in addition to whatever they paid for disposal. And that goes to the state and federal government. When we look at how they manage their waste on site, WMUs become important, and that stands for Waste Management Unit. So this is any container that is used to store waste, including a drum, other container, or a tank. So there's lots of different size containers. Most people just think 55-gallon drums, but there's some that are bigger, smaller. Then there's giant tanks that can hold thousands of gallons of something. So RCRA requires that a generator examine the Waste Management Unit, or WMU, for content compatibility, container integrity, and proper labeling. So they have to report on this every month or every time that they are required to go look at it. In this case, for containers, that's things that are small, like your 55-gallon containers, they are required to be inspected weekly, because if they were to leak, the contents aren't very much, so they're not going to have substantial risk to the environment. But if you have a tank that could be thousands of gallons, it's because it contains so much stuff, it has to be looked at every day for compatibility, integrity, and proper labeling. Because someone could have accidentally turned the valve on and knocked it as they were walking down the stairs, and it's releasing 10,000 gallons of hydrochloric acid, for example. So that wouldn't be a good thing, right? So we need them to look at it daily. During the routine inspection of a WMU at a facility, the waste generator is required to document the following. Is the container open or closed? Because the rules require that the container be closed. Is the container in good working condition, or is it leaking? Is it corroding? Is it compatible? Is acid in metal containers where it should be in some kind of plastic container instead? The kind of dull moments, but you'd be surprised what you can find out there. And is it properly labeled? So I promised you in the last lecture I'd link, when it came time for the OSHA labeling, to this part. OSHA requires that the contents of regulated OSHA businesses on a hazardous waste label, but that doesn't apply to everybody, because not every business meets OSHA requirements to be regulated by them. So your really tiny small businesses that are less than the amount of employees that OSHA requires to be considered OSHA regulated only have to have the following things on their waste labels. So bottom line, let's take OSHA out of the radar screen. According to RCRA, there's only two things that ever need to be on anyone's waste labels, and the words hazardous waste is the first part, and the second is the start accumulation date. And you might be going, what does that mean? It means the moment they started putting hazardous waste in that bucket. So what does that link back to? Remember how the LQGs and SQGs had time limits, like LQGs had 90 days to get rid of their waste, and SQGs had 180s, and C-squigs had absolutely no limit? That's what that links back to. So that's a common violation, that people don't have a start date on their labels, and it's required by RCRA. But interestingly enough, RCRA does not require the contents be put on there. So I don't know if someone was sleeping in Congress when they wrote this. Not my place to say. OSHA fixed that for the most part by making their regulated businesses put the contents according to their rules. So that brings us to waste disposal. Waste disposal is an important part of what the waste story is, because we need to make sure it's properly disposed of from cradle to grave, right? So that brings us back to that manifest I showed you earlier. There are 4 pieces, and the 4 pieces are important to showing and demonstrating in good faith that your waste was properly disposed of, handled, and stored forever, right? So the hazardous waste manifest, any registered hazardous waste generator is required to use EPA's manifest, and there's 4 different colored carbon copies. Don't get me started on the carbon copy thing, but it is what it is, and it's like a chain of custody form. So the top copy, the one that everyone signs, is actually the bottom one, the white copy right here. So let's talk about and start with the green one, because the green one is actually at the bottom, and you take it off from bottom to top, and it'll make sense in a minute. The green copy is the copy that the generator keeps the day that their waste is picked up by their transporter. So that gives them evidence that they've turned their waste over to a transporter, and the transporter is carrying it to a destination that the generator has selected. The yellow copy, the transporter keeps this copy when they deliver the waste to the hazardous waste treatment, storage, and disposal facility. That's what a TSDF is. Good test question. Treatment, storage, disposal facility. So they keep the yellow copy, the transporter does. Well, that means that the treatment, storage, disposal facility, TSDF, must keep the last colored copy, which is the pink colored copy. Keep in mind there's been a white copy on top of everything, which is the original, and everybody signed that along the way. So the white copy is now in the possession of the TSDF. It is their responsibility to mail that back with all the signatures showing that the waste actually made it to their destination safe and sound, and that it's been disposed of properly, to the generator within 45 days. So if they don't get it back in 45 days, that should send a red flag up to the generator as something may be wrong with my waste. That leads me to an exception report. An exception report occurs whenever a registered hazardous waste generator does not receive their white copy back, which is the original, the one that's on top, right? The one that gets sent back to them. So if they don't receive their white copy back of the hazardous waste manifest, the facility is required to file an exception report with the EPA/State Department of Environmental Quality. So the generator submits a copy of their green-colored manifest within 45 days of the waste pickup date. And this includes the details of all the correspondence they've attempted with the transporter and/or the treatment, storage, and disposal facility. And it doesn't get them off the hook, but here's the idea, is if we get tons of these coming in of exception reports for the same transporter company, that should send a red flag up on the regulatory side of maybe we've got a crummy bad actor here. And so it just allows a red flag to be sent up when necessary. Most of the time, it's just because people fell behind, they were on vacation, it's not a big deal. The transporter or just the transfer, disposal, storage facility just hasn't gotten it back to them, and usually a phone call will resolve it. But there are times where that exception report sends up a pattern and a flag for a specific business that probably doesn't need to be in the business of transporting waste. So let's take a break here, and we'll come back and learn about the other types of waste. See you back in a few. Bye.